If you were to take every ounce of gold ever mined by human hands, from the artifacts of ancient Mesopotamia to the bullion bars sitting in the Federal Reserve today, and melt it all down, it would form a cube measuring roughly 22 meters on each side. That is it. The entirety of our obsession, the cause of countless wars, the foundation of empires, fits into a space that would barely fill 3 Olympic-sized swimming pools. For thousands of years, this scarcity has been the absolute law of value. Roughly 216,000 tons have been extracted in all of human history, and shockingly, 2/3 of that total was dug up only within the last 70 years. We are tearing the planet apart for a metal that is vanishingly rare. But recently, the geological world was shaken by a discovery that defies the laws of scarcity we have grown accustomed to. In a remote survey in China, the ground yielded a secret that borders on the unbelievable. This wasn't just a standard find. It wasn't just a large deposit. Geologists are calling it a supergiant. Initial explorations by a team of geologists uncovered 40 distinct gold veins holding approximately 330 tons of ore. That alone would be a headline-making discovery. But when they employed advanced 3D modeling to peer deeper into the crust, down to a crushing depth of 9,800 feet, the data revealed something staggering. The gold didn't stop. It went deeper. Current projections suggest this single location holds a deposit of nearly 1,000 tons of gold. To wrap your mind around that number, at today's fluctuating market rates, that is approximately $83 billion sitting in one concentrated location. It is an amount of wealth that could alter the GDP of a small nation. But in the high-stakes world of industrial mining, the total dollar sign is actually less important than the grade. The grade is the ratio of gold to waste rock. Most modern mines operate on razor-thin margins, shifting literal mountains of earth to find dust. If a mining corporation finds a ton of rock that contains just 0.35 grams of gold, they crack open the champagne. That is considered a highly profitable, awesome yield. The ore in this new Chinese supergiant, it contains an estimated 4.9 grams per ton. That is 14 times the industry standard. It is a concentration of wealth that is almost unheard of in modern geology. If these surveys are confirmed by extraction, this site will eclipse the legendary South Deep mine in South Africa to become the undisputed largest gold mine on the face of the earth. News like this triggers a very specific reaction in the global markets. Panic and euphoria mixed together. Investors scramble, governments take notice. But if we step back from the stock tickers and the frantic buying, we have to ask a fundamental question about human nature. Why? Why do we care so much? Why does a soft yellow metal hold a psychological grip on our species that is stronger than steel, more coveted than land, and more trusted than the paper money in our wallets? The answer is not just about vanity. It is about chemistry and the fear of time. If you look at the periodic table of elements, you begin to realize that gold is the only logical choice for currency. Most other elements are tragically flawed. Iron is strong, but it is doomed to rust, oxidizing until it crumbles into red dust. Copper turns green and corrodes when exposed to moisture. Aluminum is too light and lacks durability. Then you have the noble metals. Silver is beautiful, but it tarnishes, it scratches, it reacts with sulfur in the air and turns black. Platinum and palladium are incredibly durable, but they are too rare to act as a global currency. You simply couldn't mint enough coins to run an economy. Gold is the survivor. It is chemical immortality. It does not rust. It does not corrode. It does not interact with the atmosphere. You could take a gold coin from a sunken Spanish galleon that has been sitting in salt water for 300 years. Wipe off the silt and it will shine as brightly as the day it was minted. In a world where everything else decays, where governments collapse, where paper currency is inflated into worthlessness, and where buildings crumble, gold remains. It is the ultimate hedge against chaos. It represents the one thing human beings cannot manufacture: permanence. However, desiring this permanence and actually acquiring it are two very different things. The reality of gold mining is not the romantic image of a prospector panning in a gentle stream. It is a violent, industrial war against the earth. Locating a deposit is only the first step, and it is the easiest part. The real challenge is the extraction. Gold is almost always trapped inside hard rock, scattered in microscopic particles invisible to the naked eye. To get it out, you have to move mountains. The process begins with destruction. Massive drills bore into the crust, followed by charges of dynamite. The ground is shattered, blasting the rock into manageable chunks. But these chunks are just worthless stone to the naked eye. They must be hauled to processing plants, where the energy consumption skyrockets. First, crushing machines, giant steel jaws, grind the boulders into gravel. This gravel is then fed into rotating drums filled with heavy steel balls. As the drums spin, the balls pulverize the stone into a fine, flour-like powder. But the gold is still trapped. To release it, miners have to use chemistry. This powder is mixed with water to create a slurry, which is then flooded with solvents, often cyanide. The cyanide leaches through the powder, dissolving the microscopic gold particles into a liquid solution. It is a toxic, dangerous process that requires immense precision. From there, the liquid gold is stripped from the solution using activated carbon, subjected to electrolysis, and finally melted in furnaces reaching over 1,000 degrees Celsius. The impurities burn off. And finally, the molten yellow liquid is poured into molds. It is an exhausting, expensive, and environmentally taxing ordeal. This is why the grade of the ore matters so much. For most of the planet's deposits, this process costs more than the gold is actually worth. In fact, less than 0.1% of the gold anomalies geologists find are ever turned into mines. The Earth holds plenty of gold, but it demands a high price to let it go. So when a discovery like the one in China happens, 1,000 tons of high-grade, accessible ore, it is a geological miracle. But while the financial world obsesses over this ancient metal, scientists and engineers are looking at different materials. They are looking for the substances that will build the future, rather than just store the wealth of the past. There is another substance that is often called liquid gold, but you cannot wear it and you cannot store it in a vault. It is helium. Most people dismiss helium as the gas used to inflate birthday balloons, a trivial party trick. But in the scientific and medical worlds, a helium shortage is a terrifying prospect. Helium is unique. It remains liquid at temperatures lower than any other element, making it the ultimate coolant. Without liquid helium, the superconducting magnets inside MRI machines would overheat and fail. Modern medical diagnostics would essentially collapse. It is used to cool nuclear reactors to prevent meltdowns. It is essential for pressurizing the fuel tanks of rockets. Without it, space travel becomes exponentially more difficult. Deep sea divers rely on helium-oxygen mixtures to breathe at depths that would otherwise kill them. The problem is that helium is finite. Unlike gold, which can be melted down and recycled endlessly, helium is a gas. When a balloon pops or a tank leaks, that helium rises into the upper atmosphere and is stripped away by solar winds. It leaves the planet forever. We are burning through our reserves of this critical element. And unlike gold, once it is gone, it is gone. And then there is the material that makes gold look like a relic of the Stone Age, a material that promises to rewrite the rules of technology: graphene. If gold is the champion of the old world, graphene is the architect of the new one. It is derived from graphite, the humble, soft gray material found in pencil lids. But when scientists isolate a single layer of graphite, just one atom thick, arranged in a honeycomb lattice, it becomes something extraordinary. Graphene is one of the strongest materials known to science, roughly 200 times stronger than steel by weight. Yet it is incredibly flexible. It is transparent. It is water repellent, non-toxic, and antibacterial. But its true potential lies in energy. Graphene is a superconductor of both heat and electricity. It conducts electrons with almost zero resistance. This property alone could dismantle the limitations of our current technology. Consider the batteries in our devices and electric cars. They are heavy, slow to charge, and degrade over time. Graphene batteries, which are currently being tested, shatter these limits. They have shown the ability to charge nearly 70 times faster than standard lithium-ion batteries. Imagine plugging in your electric car and having a full charge in the time it takes to drink a cup of coffee. Imagine a smartphone that charges in seconds and lasts for days. Furthermore, graphene batteries last 3 times longer before degrading, and they do not require the heavy, toxic mining associated with cobalt or lithium. They are cleaner, faster, and more efficient. Scientists believe graphene will spark a revolution comparable to the discovery of silicon. Without silicon, we would have no computers, no internet, no digital age. Graphene stands poised to launch the next era. From desalination plants that turn ocean water into drinking water, to bionic devices that merge with the human body, and the raw material for this revolution, it is already here. One of the largest graphite deposits in existence is located in South Australia, holding over 200 million tons of high-quality ore. It is a reserve vast enough to supply the entire planet's transition into this new technological age. So as the headlines scream about the $83 billion of gold found in China, it is worth keeping a broader perspective. Gold will always be the king of currency. It is our safety net, our history, and our symbol of enduring value. It is the metal we hoard when we are afraid of the future. But the materials that will actually build that future, the helium that keeps our hospitals running, and the graphene that will power our energy grid, are where the true utility lies. The 1,000 tons of gold is a treasure, certainly. But the graphite and the helium, those are the keys to our survival. If you enjoyed this deep dive into the hidden wealth of our planet, make sure to hit that like button to support the channel. It helps us continue to uncover these stories. And if you want to stay ahead of the curve on the discoveries that are shaping our world, be sure to subscribe. Until next time.